So I got a request to go over the problem that we had assigned in class on, I guess it was Monday. So we have a piece of metal. It has a mass of 59.047 grams. So let me go ahead and write everything down as I go through the problem, translate it. Need to put that into kilograms. And it has a temperature of 100 degrees C when it starts off. So T metal initials 100 degrees C. And we're going to put it into 100 grams of water. Again, I got to put that into kilograms, so that's 0.100 kilograms. Then the water is initially at 23.7 degrees C. I'm told that eventually the metal cools down, the water warms up until T final is 27.8 degrees C. And so we're going to assume that if there's no heat lost in the environment, so it's an isolated system, we want to calculate the specific heat of the metal. So what we know is if it's isolated, that means that the heat that's lost by the metal is equal to the heat that's gained by the water. And again, I put in absolute value signs to indicate that we're going to make both of them positive. So what is the heat? Well, if it's temperature change, heat is mc delta T. So if I look at the water, I have everything I need to know to calculate the heat for the water. I've got the mass of the water. Specific heat for the water is given at the bottom of the problem, 4186 joules per kilogram C. So I've got mass of water, and delta T for the water I can also put in. So let's put in our number. So mass of the water is 0.1 kilograms. The specific heat of the water is 4186. And the change in temperature, it starts off at 23.7. It goes up to 27.8. And remember, I want to write that so that I get the change as being positive. So I'm going to do 27.8 minus 23.7. And so if I plug all that into my calculator, I get that the heat that's gained by the water is 1,716.26 joules. And I'm going to keep a bunch of sig figs right now. All right, so I know the heat for the metal is equal to the heat for the water, and I've got a number now for the heat for the water. So I know that my heat for the metal must also be equal to the same amount because it's an isolated system. And what's the heat for the metal? Well, it's mc delta T, so it's the mass of the metal times C for the metal times delta T for the metal. Okay, so the mass of the metal we have is 0.059047 grams. Specific heat for the metal we don't know. Delta T for the metal, now I've got to make it positive. It starts at 100 and goes down to 27.8. So to make that difference positive, I'm going to have to do this. And again, that's equal to the same amount as for the water, so 1716. So multiply all my numbers together, and I get 402. Sorry, going a bit ahead of myself. I get 4.2632 times Cm, which is what I'm trying to find. The specific heat of the metal is equal to 1716.26. Therefore, the specific heat of the metal, just divide out the 4.2. And I get 402.6. And let's see, how many significant figures do I have? Let's say I got 1, 2, 3, 4, 5 in the mass, 4 in that temperature, 4 in that mass, 3 in the temperature, 3 in the temperature. So I got to stick with 3. So I'm going to round that to 403. And the units are going to be joules per kilogram degree C. Okay, so that's all there is to it.